meron na naman tayong bagong module. Oh. Ay, ano naman yan? Ito? Ha? Teka. Siya ay LED module. Binili ko yan, ganyan na. Naka-module. 3 pins. Oy, anong ano yan? Ha? Aba? Alam mo ba kung ano ito? Ito yung tinatawag na bicolor LED. Dalawang kulay niya. Ah. Asan yung kulay niyan? Ay, testingin natin. Gamitan natin ng pan-testing. Adjustable power supply. Makikita mo kung paano mag-magic. Ha? Kakabit ko ha. Okay? Ayan oh. At yung isa, delikadong mag-short. O, itong isa, doon. Kabilang dulo. Okay? Teka. Ayan. Lagyan natin ng voltahe. Oh. Di ba umilaw? Anong kulay niya? Di ba kulay green? Ah, yellow. Yellow yan. Oop. Bakit naging pula? Green. 21 milliampere. Sakto lang yung amperahe niya para sa LED. 20. Sa 2.29 volts. Gawin nating 2 volts. 13 milliampere. 2.08 volts. Di ba? Ay, asan naman yung kulay ng isa niyan? Ba? Teka. Lipat natin. Ha? Oops. Ayun. Kulay pula siya ngayon. Masyadong malakas ang voltahe. Oy, nalaglag na. Dapat mga 1.8 lang. Kabit uli natin. Yun o. Oh. Diba? Pula? Yellow. Ayun o, mahina ang voltahe niya sa 1.8. Kailangan mga 2 volts. 2.5 pag yellow. Pag red, mga 1.8. Ayun o. 1.8 kulay red. O, di ba? Magmamagic ako. Lalagyan natin ito ng driver. At doon mo makikita kung paano ko mag-magic. Teka. Ito na ang ating LED driver. Oh. Meron siyang IC NE555. Ano pala? LMC555 CMOS type. 555 timer, CMOS. Meron ding transistor at mga resistor at may capacitor. Nasaan yung ano yan? Ito. Lalagay na natin sa driver. Magiging magic na siya. Lagay natin. Nakakonekta na ang ating LED. Gamitan natin ng supply. 9 volts. 9 volts yan. Masyadong maliwanag. 9 volts. Rechargeable battery. At connect natin. Patayin ang ilaw. Magic! Lapitan natin. Ano ang nakikita mo? Ayun, Yan ang aking magic. Yung kulay red na LED nagiging green. Alternate. Diba? Iisang LED bulb lang yan. Yung red nagiging green, green, red. Ilapit natin. Diba? Uy, nalaglag. Yan na uli ang magic. Diba magic yan? This is now the circuit diagram of our circuit. LED bicolor driver LMC555. Our supply is 9 volts. BDD referring to the supply of the CMOS IC. But we can also use BCC referring to the supply of the transistor. Okay? So for our supply, we have 9 volts. And then, we're going to add this power indicator. Composed of 2.2K resistor and red LED. We're going to add this power indicator. And into our circuit, we have this 555 timer LMC. This is a CMOS type 555 timer. CMOS type, the output of the 555 timer is a CMOS type MOSFET. Okay? And the pin 1 of this 555 is ground. Pin 2 and pin 6 is connected to each other through a capacitor of 10 microfarad 25 volts electrolytic capacitor to the ground. Also, we have this feedback resistor from the output 3. 3 is the pin number 3 output with a resistor of 33K. Feedback resistor to the input. Okay, capacitor of 10 microfarad 25 volts. And pin number 5, no connection. Pin number 7, no connection. Pin number 8 is the power supply of the IC. Pin number 2 is the trigger. Pin number 6 is the threshold. Okay. What is the configuration of this circuit? Up to this point, this circuit, it is configured as an oscillator. It is as a oscillator, it is capable of producing a square wave into the output. On, off, on, off, on, off. That is the oscillator. So let us see the internal diagram of this IC so that we know that it is an oscillator. Okay. This is the internal diagram of the 555. The only difference is the output transistor, which is connected to the pin number 7 discharge, is CMOS, but here it is BJT, but the function is the same. So inside the 555 timer, we have two comparator. In our circuit, pin number 6 is grounded through capacitor. So it's grounded, so it receives 0 volts. Because the capacitor is charging. Then also grounded is pin number 2. As you can see in the figure, grounded by the capacitor. So pin number 2, the other comparator, it is 0 volts. 0 here. So if this is 0 volts, level 0. How about the other pin of the comparator 1? It is connected with the 3 resistor, voltage divider. There is a resistor inside the IC. So if you measure the voltage across this inverting terminal, we can measure 2/3 of the supply voltage. Since our supply voltage is 9 volts, we can have this 6 volts. 2/3 of 9 volts, 6 volts. If this is 6 volts and this is 0 volts, so the level of here is 0, low level, and then 6 volts, 1. High level, 1. It is according to the digital electronics. And if the inverting terminal is greater than the non-inverting, which is 6 volts greater than 0 volts, it will output a signal, inverted signal, or inverted output. If this is 1, it becomes 0, low level. How about this one? We have another comparator connected to the 1/3 of the BCC, or 9 volts. 1/3 of the 9 volts is 3 volts. But 3 volts is greater than the 0 volts because pin number 2 is grounded, 0 volts. So these 3 volts become high level or on, and this 0 volts, 0. And for the comparator, if the non-inverting terminal, the positive non-inverting terminal, is greater than inverting terminal, it will output the same with the input. If the input is 1, it becomes 1 into the output. So there are two outputs, 0 and 1, going to be feed to the another circuit, RS flip-flop. So this is 0, reset, and set. This is another circuit in digital electronics. 0, reset. The complement of 0 is it's direct, just 0. Reset is complement with the, reset is the same with the output. But here, if set is 1, it will be complemented, inverted into 0. 1 into 0. So the output is 0 for this circuit. If this is 0, we have the buffer here. If the this is we have the inverter. If the input is 0, since this is inverter, it inverts the signal again into 1 or high level. And since we have the output connected to the load, the LED, it will output or it will turn on the LED. So it means we have an output, initial state, to the pin number 3. If we have an output, it is outputting a high signal. High signal. So the current will flow into the out, charging this capacitor. As we know, it is charging 33. And also, how about to this transistor? It will reverse bias this transistor because this is a PNP type transistor. The current will not flow into this transistor. It is open. This is reverse bias condition. The current will only flow, or this transistor will only switch on when the current flows into the emitter to the base. But here, the current flows from base to emitter. So this is reverse bias, open, as if there's no transistor here. And then, since we have this output continuously charging the capacitor, also current flows into the base of this transistor. This is a biasing resistor. In order not to burn out this transistor, so we need this biasing resistor of 1K. So the current will flow into the base, into the emitter, switching on this transistor. This transistor now is on. That is the characteristic of NPN or the NPN BJT type. This one is PNP and this one is NPN. If the current flows into the base, into the emitter, it will switch on the transistor. That is the characteristic of current flow in this transistor. So it will switch on this transistor. Now the current flows into the collector to the emitter through 470 ohms resistor and turning on this green LED. And the red LED is turned off. So red LED turn off, green LED on. On. This is off. Why is it off? Because transistor here is reverse bias. There's no way the current will flow into this transistor because our 555 is outputting a high level signal. And you can see here, why is it that there is a green and red color into the LED, that changing its color. Why is it changing its color? Because it has two LED inside the bulb. The characteristic of bicolor LED is it has two LED, which is green and red, constructed inside the bulb in just one bulb. So for the meantime, or for our initial state of the circuit, green LED turns on. Okay, the moment that this 555 will produce a low signal, okay? Low signal, since this is oscillator, the current will now flow into the emitter to the base of this transistor. This transistor now is on. This is PNP. And the current flows inside the 555. And then since it's switching on this transistor through emitter to base via 10K biasing resistor, now the current will also flow into the emitter to the collector with the current limiting 4.7K resistor through the until or to the bicolor LED. Now the red LED will turn on. Okay? So the current will not flow into this transistor. It will becomes off, turns off. Why? Because the current flow into the 555. At that time, at that moment, the capacitor now is discharging through this feedback. Before, it is charging. Now, it is discharging to 33K and into the 5x5. And this transistor will turn on via emitter to base, switching this emitter to base and through the pin number 3, turning this or saturating this transistor or function as a switch. And what will happen to the LED red color? It will turn on because this transistor is on. Red LED turns on, and if this transistor is on, green LED turns on. So there is a alternate flashing of the LED. It becomes green, then turns red, red turning to green, green, red, because of the alternate switching of the two transistor. And the output of the 555, it is capable of receiving signal from outside and then sending, receive, sending, receive, sending. It is a two-way outlet, just like a two-way bulb.